In this video, the learner will determine the lateral surface area and total surface area of both pyramids and cones. So we've all seen the pyramids in Egypt. We're used to seeing pyramids with a base that's a square, but there are other types of pyramids, and we're going to experience finding the area and volume of those in the next couple of lessons. First, we need to go over some parts of pyramids. I have both the polyhedron view and the net view to identify some different parts here. The vertex of that pyramid, it actually does have a special name. It's called the apex of a pyramid. Apex just means the very top of something. So that vertex at the top is the apex of the pyramid. From the apex all the way down to the center of our base is the height, and we're going to call that h in some of our formulas. Notice from the center to the side of the base, well, we know from area of figures that the center to the side is the apothem. So we actually have the apothem represented in the polyhedron here. So if I take a look at just the base here, from the center to the side is the apothem. Notice the apothem and the height make a right triangle, and then we have that hypotenuse that we call the slant height of the pyramid. That's going to be the height along the slant. That's why it's called the slant height, and we'll call that L. The base picture and this height triangle are going to be really important as we start to solve problems. In the net, we have our base, so that base shape. We have our lateral faces that are all triangles in the pyramid, our lateral edges, and then our slant height. Notice our slant height is from the apothem, where the apothem meets the side, to the apex. So where the apothem meets the side to that apex, that's our slant height. Notice that's going to be different from our lateral edge. Alright, so we have a square pyramid that has base edges of 10 and a slant height of 13. So that slant height is from the apex down to the edge of the base. What we're going to do is find the height of the pyramid. That's from the apex to the center of our base. So we know on our base, if we drew the apothem, that would cut each side in half, and we would know that we have a 45, 45, 90, so we know the apothem is going to be 5. In our right triangle that's formed with the apothem, height, and slant height, we now know what the apothem is, which is 5. We know what the slant height is, L of 13. So now we're just going to use Pythagorean theorem to find that third side to find the height. So we have 5 squared plus x squared equals 13 squared. So 25 plus x squared equals 169. Subtract 25 from both sides to get 144. Square root to get x equals 12. So now we know the height of this is 12. So we're going to be using this height triangle to help us solve for missing pieces. And we'll also use our base to be able to find our apothem to help us find the area of our base. Now let's take a look at some formulas here. The lateral area of a pyramid is going to be the sum of the areas of the lateral faces. That's going to be the sum of the triangles that make up the lateral faces. So we have a formula of lateral area equals 1/2 perimeter times slant height. The 1/2 P times L will just be the sum of the lateral faces. So to get the total area, we have to add in the base. So it's the lateral area, 1/2 p times L, plus the area of our base. As a reminder here, we know the perimeter of the base is P, B is the area of the base, L is our slant height, and H is our height. So here we want to find the lateral area and total area of the square pyramid below. Notice we are given our base edge of 12 and we're given a height of 8. So what I'm going to do is draw that height triangle in our base shape, and we're going to use that to find the parts. So we're given a height of 8. We can find the apothem and slant height using this height triangle. So let's go ahead and start using what we know to find P, B, H, and L to be able to plug into our formulas. So for P, the perimeter of our base, well, this is a square pyramid, so we know all of the sides are going to be 12. So 12 times 4 is 48 units. The area of the base is going to be the area of the square. We can find the area of that square using the area of a rectangle, so length times width, or base times height, is going to be 12 times 12, which is 144 square units. We know the height is 8 units, and we're going to have to find the slant height in order to plug L into these formulas. To do that, we have to use our height triangle. Well, we know our height is 8. We know from our base that we would cut that base in half to be 6 and 6. We know if we drew that radius, we'd have a 45, 45, 90, so we would know this half of the base that's 6 would also be the length of the apothem. So we know our apothem is going to be 6. Now we have two sides of that right triangle, so now we can use Pythagorean theorem to solve for the third side. 6 squared plus 8 squared equals x squared. When we solve Pythagorean theorem, we're going to get 10 units. So our slant height is 10. Now that we have P, B, H, and L, we're going to plug in to lateral area and total area formulas. So we have 1/2 perimeter times slant height. For lateral area is 1/2 times 48 times 10. So 48 times 10 is 480 divided by 2. And that's 240 square units. Our total area is 1/2 48 times 10, that was our lateral area, and then plus big B. We only have one of the bases here. So 1/2 48 times 10 was our 240. 240 plus 144 is 384 square units. The regular triangular pyramid has a base edge of 32√3 and a slant height of 34. So we're going to go ahead and label those pieces on our height triangle and on our base shape. We want to find its lateral area and total area. In order to find lateral area and total area, we're going to need P, B, H, and L. So we know right now that our base has an edge of 32√3. We can find the perimeter of that base by just multiplying that by 3 to get 96 square root of 3 centimeters. That's the perimeter of that base. To find big B, we're going to have to find the area of this equilateral triangle. So we're going to need to use that 30, 60, 90 here with 16√3 as our 60 to find our apothem of 16. Once we know our apothem is 16, we already have the perimeter. We're going to use the formula for big B of 1/2 apothem times perimeter. So big B is 1/2 times 16 times 32√3, which gives us 256√3 square centimeters. Now I have to find H and L. So I know that my apothem is 16. My apothem is also the length of that base in my height triangle. I could use Pythagorean theorem to find the other leg of that right triangle. So I have 16 squared plus x squared equals 34 squared. 256 plus x squared equals 1156. X squared equals 900, so x is 30. So the height is 30, and we were given that the slant height was 34. Now we just plug in 1/2 perimeter times slant height gives us a lateral area of 1728 root 3 square centimeters. Then we add our base to that, 256 root 3, and get a total of 1984 root 3 square centimeters for total area. Notice that these were like terms. The 1728 root 3 and 256 root 3 both had a root 3 with them, so we could add them together to get that 1984. I want you to try this example. We're given a base edge of 20 root 3 inches and a height of 24 inches. Here we have a regular hexagonal pyramid. We know that the base edge is 6, and we have a slant height of 14. So we already know our L value is 14. We need to find P, B, and H. So to find perimeter, we know that this is a regular hexagonal pyramid, so 6 times 6 gives us 36 centimeters. We need to find the area of the regular hexagon using our apothem formula. We know that this half of the side will be 3. Therefore, across from the 60 in that 30, 60, 90 triangle will be 3 root 3. So we know our apothem is 3 root 3. To find the area of the base, we have 1/2 apothem times perimeter, which gives us 1/2 times 3 root 3 times the 36 that we already found. 36 times 3 divided by 2 gives us 54 root 3 square centimeters for the area of the base. To find h, we're going to have to use Pythagorean theorem. We know our apothem is this side here in our right triangle, 3 root 3. It corresponds to this piece in our hexagon in the pyramid, from the center of our base to the base edge. Now we have to use Pythagorean theorem. We have 3 root 3 squared plus x squared equals 14 squared. 3 root 3 squared is 27 plus x squared equals 196. Subtract 27 from both sides and then square root to get 13. So our height is 13. Now we just plug in for lateral area and total area. Lateral area is 1/2 times 36 times 14, which gives us 252 square centimeters. Now we add our 252 plus our 54 root 3. Notice those are not like terms, so we can't combine them, so we leave it exactly as is, as 252 plus 54 root 3 square centimeters. I want you to try this example here, given a base edge of 16 yards and a height of 13 yards. We're going to find the lateral area and total area of cones, so we need to label some parts before we know the formulas. This is the net representation, and here's our polyhedron representation. Again, the vertex is the apex of the cone. From the vertex to the center of our base is going to be the height. From the center to the edge of our base, we have the radius, because our base is a circle. So on the net representation, we also have that radius shown. We also have what's called the lateral face. Notice I have that in quotations because it's not really a face because it's curved. And along the edge of that lateral face, we have our slant height. Again, we'll have that right triangle, but this time we'll have a radius, the height, and then the slant height. So we'll have R, H, and L as the sides of that right triangle. The lateral area and total area formulas for a cone. Lateral area will be the sum of the areas of the lateral faces, but we only have one lateral surface on the cone. So to get the area of that surface, we'll have the formula pi RL. So we'll have pi times the radius times the slant height. For the total area, we'll need to add in the area of that circle as our base. So we'll have that lateral area of pi RL plus the area of our base. Just as a reminder, B is the area of our base, R is the radius, and L is the slant height. And we're going to use that height triangle to help us solve for missing pieces, where R is the bottom on the base, from the center of the base to the edge of that circle. From the center to the apex will be that height, and along that curved lateral face will be our slant height. For this cone, we're going to find its lateral area and total area. So we need to find big B, our radius, and our slant height. Notice we're given the 15, that's from the center to the edge of the circle. That's going to be our radius. So we know we can find big B by doing pi r squared. Pi times our radius squared will be pi times 15 squared, which would be 225 pi square units. We already know that our radius is 15 units. That's also going to be this bottom piece in our height triangle, a radius of 15. We see here in this right triangle, the hypotenuse of that right triangle is going to be 25. That represents the slant height along that cone. So we already know our slant height is 25. We could use Pythagorean theorem to find the height if we needed it. So now we have our big B, our radius, and our slant height, so we can find our lateral area and total area. So we'll have lateral area, which is pi times r times L. So pi times 15 times 25 gives us 375 pi square units. For the total area, we need to add in the base, so we'll have our 225 pi plus the 375 pi that we found previously for lateral area, which gives us a total of 600 pi square units for our lateral area. I want you to try this example given a radius of 7 and a height of 24.